Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to wrap up our discussion of file system forensics by talking about extended attributes and showing you a little bit of Python that we can use in order to get extended attributes out of our image files. So here I've created a simple little Python program where I import all the usual things. I have a usage function, and I expect an image file, the offset to the start of your file system, and an inode number. I do the standard thing. I first will open the image file. I will create an extended metadata object. I will get the location of the inode using stuff that's stored in the super block and in the group descriptors. From there, I will go ahead and read in the appropriate inode. I used our good old friend with open, the recommended construct for Python, and then I create an inode object. And I figure out, does this have extended attributes? We'll see we've extended this inode class just slightly. And if it does, I'm going to look at the block number for the extended attributes. If it's set equal to 0, that means these extended attributes are stored in the empty space between this inode and the next inode. Recall that the inodes are currently 156 bytes long if it's an ext4 file system, and pretty much that's what we're talking about right now. If you're looking at older file systems, they don't support this. You have 100 bytes from the 156 byte where the inode ended to the 256 byte on disk where the next one starts. So if this block is set to 0, it's stored there, and I will get the extended attributes from my inode, and I will pass all the standard information that I need. This should point to the start of the extended attributes right after the inode is done. And this method says, oops, it's actually stored in an external block, which is also supported. So this method will get it from there, and then I use a for loop in order to print out the attributes that I found. If there weren't any, I just say there weren't any, sorry. We'll have a look now at our additions to our extfs py file. And I've added this method, get extended attributes in an inode with the appropriate parameters. I start out by defining an empty dictionary, and then I check the magic number. If that's not what I have, I'm going to short circuit and return my empty dictionary. Set done equal to false. Start my index 4 bytes in, because I'm skipping over this. And while I'm not done, I'm going to get an extended attribute entry, and I'm going to check and make sure it's not the end of the list. Then I will say, is this extended attribute stored in this block? Is it inline, if you will? Or is it in an external block? If it's in an external block, I call get data block, and then I will get the information from there. A couple of little helper methods and classes. Here's my extended attribute entry class. Starts out with a name length, index, value offset, value block. Again, 0 means the current block, the size for the value, and also a hash. I give it a name the name is going to be equal to the name that's stored, but with a prefix added. And we've talked about these prefixes in previous videos. So here we have a method to print these prefixes. And if it's 0 or greater than 8, which means I don't know what it is, I just return an empty string. Otherwise, I return one of these. So that is the method for getting extended attributes inside of an inode. The one for getting attributes stored in a data block is very similar. Let's go ahead and run this real quick. I will run iGetAtterPy on an image with an offset of 2048. And I will look at one of my interesting inodes. Sure enough, it tells me it has no extended attributes. In fact, if you were to look through this file system, you would see that none of these have extended attributes. As a reminder, you can do the same thing using the tools. If you mount the file system, you can use getFadder and setFadder, which you wouldn't want to do if you're looking at another image. That wouldn't be good forensics, certainly. And you can look at it that way as well. But this is just another way, and I wanted to show you how you could modify our Python in order to do it with an image of a file system that's not currently mounted. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.